Welcome to the Mechatronics Revolution Fundamentals and Core Concepts. In this lesson, we'll talk about microcontroller specifications. The objectives of this lesson are to define key microcontroller specifications. We'll review the specifications of some common microcontroller kits, and finally, we'll discuss design features of microcontroller development kits as well. Here we have 4 microcontroller development kits that you can buy commercially. Each of these different microcontrollers has different memory characteristics, different word size characteristics, different numbers of input-output ports, etc. So it's important to understand the different types of specifications that a microcontroller has, and then which specifications are important for a particular application. And those are some of the things that we're going to talk about in this lesson and going forward as well. First, let's talk about the word size of a microcontroller. So when we talk about processors, sometimes we hear the word 8-bit processor, or 32-bit processor, or 64-bit processor. When we say 8-bit or 32-bit processor, that refers to the word size of a processor. The word size is the size of the internal data registers that the processor uses to perform computations. Now, a larger word size means that a microcontroller can process more data at once because the internal data registers are larger. For example, a floating point decimal number takes up 32 bits of space. So that can only be processed by a microcontroller that has a 32-bit data register. So that microcontroller has to be a 32-bit microcontroller. It has to have a 32-bit word size. So let's look at some examples. Here we'll compare a high-performance, high-precision processor with a lower precision or smaller word size processor. So for example, a 32-bit processor has higher precision and a bigger word size. So it'll have a higher speed, meaning that the time it takes to do a particular operation will be lower. However, it can draw more power. It can be more complex to program and is usually more expensive to buy a 32-bit processor. On the other hand, for instance, an 8-bit or 16-bit processor may have less capability in terms of computing performance, but also draws less power, and it's usually less expensive. And for a lot of embedded applications, that can make a big difference. Now, various market analyses of microcontroller sales have shown that over the past decade or so, 8-bit microcontrollers are about equally as popular as 32-bit microcontrollers. So if you look at how many microcontrollers have been sold, about equal parts 8-bit and 32-bit microcontrollers. So why would an 8-bit microcontroller, which is, say, less powerful or less capable computationally, why would that be equally as popular as a more capable computer, a more capable microcontroller, a 32-bit one? The reason is because many embedded applications are simple and require minimal computation. For instance, a dishwasher doesn't really do a lot of heavy calculation, and so you can usually use something like an 8-bit microcontroller or a 16-bit microcontroller for things like a dishwasher, a toaster, etc. So cost and power considerations for simpler embedded applications mean that an 8-bit microcontroller could be more desirable than a more expensive 32-bit microcontroller, particularly because we don't need all the extra computation performance that a 32-bit microcontroller gives us. Now, a microcontroller itself is just a small integrated circuit that just looks like a little black IC package with a lot of pins, maybe dozens of different pins. Now, to use one of these little integrated circuit computers for prototyping, it needs to be paired with a breakout board. For instance, check out the diagram that's shown on this slide. We have a microcontroller, which is that small black package. When we combine it with a breakout board, we get this thing called a development kit. So a development kit is a microcontroller on this breakout board that allows us to easily connect wires to each of the microcontroller pins. The actual pins on the microcontroller are really small and hard to access with things like wires and so on as we're doing testing and prototyping. So that's what the development kit is for prototyping and ease of connectivity. Texas Instruments builds a line of development kits for their microcontrollers called Launchpads, and that's what we'll use in this course as an example. If we take a look at the MSP432 microcontroller made by Texas Instruments, Here's a pinout diagram of the MSP432. So this is a 32-bit microcontroller, and it has 100 pins. This is a labeling of each of those 100 pins. The actual package is extremely small, and when we try to use, we'll need several of these pins as we're doing prototyping, so it's very difficult to access these pins directly. So when we have this package on a Launchpad board, we're able to connect wires to it and do prototyping much more easily. Here's a close-up view of the MSP432 Launchpad development board from Texas Instruments. When this microcontroller is integrated into this development board, it becomes very useful for prototyping purposes. There's several key elements that are important. There's a USB connection to a PC, and there's header pins that allow you to connect GPIO pins or input-output pins from the microcontroller to external devices such as sensors and motors and servos, etc. They also allow you to power the microcontroller from a battery quite easily. Let's take a look at some common microcontroller development kits that are available. The first one is the common Arduino. It's quite popular. It is a 32-bit microcontroller that's made by Atmel. 96 kilobytes of onboard volatile memory, and 512 kilobytes of flash, and usually costs somewhere in the $30 to $50 range. This microcontroller development kit made by STMicro is another popular model that also contains a 32-bit microcontroller. This microcontroller has 192 kilobytes of RAM and 1 megabyte of flash memory, and usually costs somewhere in the $15 range. The Clicker PIC18 development kit uses an 8-bit PIC model microcontroller made by Microchip. This microcontroller is lower performance and is typically used for embedded applications which don't need complex processing or complex software. It has 3 kilobytes of RAM and 128 kilobytes of flash memory. The TI MSP432 Launchpad also has a 32-bit microcontroller, 64 kilobytes of RAM, and 256 kilobytes of flash memory, and costs about $13. Finally, let's look at the Raspberry Pi 3 Model B embedded computer. This is not a microcontroller, but rather an embedded computer. It is a 64-bit ARM processor, 1 gigabyte of RAM, and actually doesn't contain any non-volatile memory, but rather an SD card is needed for non-volatile storage. The processing speed of this embedded computer is over 1 gigahertz, which is significantly more than the microcontrollers that I showed you previously. To summarize this lesson, microcontrollers are available in different word sizes that dictate their speed, their computing capability and performance, and their cost. Smaller word size microcontrollers, such as an 8-bit microcontroller, are routinely used for embedded applications where you don't need complex or high-power computing requirements, and that minimizes their cost and power. Microcontrollers are typically integrated with development kits or evaluation modules when used for prototyping purposes.